Hello everyone, I am Shruti Vijayargi from BISP Solution, and there is another video for performing regression analysis. In my previous video I discussed the simple linear regression, and now I am discussing about the multiple linear regression. Multiple linear regression is a method used to model the linear relationship between a dependent variable and one or more independent variables. The dependent variable is sometimes also called the predict, and the independent variables are the predictors. So here's the equation for multiple linear regression, where we are going to find out the relation between more than one independent variables. So y is the dependent variable because it does depends on the other independent variable a plus b 1 x1 plus b2 x2 plus b3 x3, where a and b1 b2 b3 are the coefficients and x1 x2 x3 are the number of independent variable, and they are independent, but y is dependent on x1 x2 and x3. So let's look around the example. In my previous video, I discussed about the simple linear regression in which I am using the bank data, and now I am explaining multiple regression using a very simple formula. So here is the quantity sold, that how many quantities are sold in with the price of this, and they are advertising. So we are going to find the relation between quantity sold and price and the quantity sold with advertising. So just go to the data, select the data analysis, and from data analysis tools, select the regression and then click OK. Then pass the references of the cells where y is the dependent variable from cell B2 to cell B7, sorry B8, and then from X range, and X will be the range of independent variables. So there are two independent variables, price and advertising. So I select all the cells from price and advertising. Because I am not selecting the labels of these fields, so I am not check this label field, and I want my output in a new worksheet, so I select new worksheet and then click OK. So this is the output generated by the regression analysis for multiple fields or multiple independent variables. So here's the R square value, which is 0.96. That means it is 96% of what we are trying to calculate y for x. But in multiple regression, this value is not required because this is the calculation for multiple independent variable, and it will be calculated for a simple only one field, which is 0.94. That means it was 94% good to calculate y to x. So in multiple regression, this value is important rather r square. And this is the multiple of r, which is simply the square of this value. Here's the standard error, and these are the observations. So I am taking almost 7 observations. So the output is for observation is 7. Then there is the important field for ANOVA. ANOVA is the first field is for DF, which stands for degree of freedom. So the regression here is 2. That means how many independent variables we are using. So we are using two independent variables, price and advertising. So the degree of freedom for regression is 2. Then the residual is calculated like n minus k minus 1, where n is the number of terms. So number of terms is 7. Then k, here the value for k is 2 because two number of independent variables are using, and minus 1. So the value is 4. So the value for residual is calculated by n minus k minus 1, and total will be calculated by n minus 1. So the n is the number of observation, which is 7, and minus 1 for Okay. Next is the SS, which is the sum of square for the variables of regression. MS is the mean square of the regression. F, it is the statistics F and significance of F. And also notice that the significance of F must be as low as possible, and the value it shows, it is more and more small, then it will be good to use this value, and this is our correct data. And here is the coefficients, which is the coefficients calculated for all the values of the formula y equals to a plus b1 x1 plus b2 x2. So it is the intercept, and this is the values for a and b. Also must notice that the p-value must be as small as possible. So here is the p-value, and it is as small as possible. And also notice that the p-value must be less than 0.05. So here these values are less than 0.05. So all our data, all those two independent variables are good and correct to calculate. And if these values are greater than 5%, then you must leave that argument, or you just delete that complete column if the value is greater than 5% or 5%. So here the values are small as possible. So it is correct, and our regression calculation is correct for multiple independent variables. So if you have any queries, you can ask me, and thanks for watching.